welcome to today's tutorial. So in this tutorial we're going to discuss how we can find the domain of a composite function. Okay, so the question is this, rather, given that f of x is equal to 2x, g of x is equal to 1 plus x, h of x is equal to x squared, find the domain of the following functions of x. Okay, so this one is straightforward. If you have not yet subscribed to the channel, make sure that you do so by clicking the subscription button and the notification button after subscribing. Then make sure that you send your questions, if you have any, to any of these lines on the screen. Right, so let's quickly start solving the question. So we've been given these functions f of x, g of x, and h of x. Now we've been asked to find the domain of the composite functions. So this is what we have. We have f of x, and then let's find this one. So h of g of x. H of g of x means that while there is x in h of x, we'll replace with g of x. So while there is x in h of x, we're going to put g of x. So this is what we're going to do. So our h of x is x squared. So while there is x, I'm going to put g of x. So we'll have g of x there. And then we are squaring it. So I'm going to square it because x is squared in h of x. So while there's g of x there, I'm going to replace back with that. So I'm going to have so I'm going to have something like this: 1 plus x squared. So the domain of this function is simply just all real numbers. Why do I say this? Because there is no number in the set of real numbers that you can replace in this expression to make it undefined. So if you want, you can simplify this further, and you are going to have x squared plus 2x plus 1 as your quadratic solution. So there's no number that you can replace into a quadratic function and find it undefined. So if there was that number, I would have excluded it from the domain. So in this case we don't have any, hence the domain of this function is simply just all real numbers. Okay, let's quickly do the second one. So the second one is simply just f of h of g of x. So to solve this, I'm going to start with what is in the brackets, and then I'll end with what is outside the brackets. So in h, I'm going to replace g of x. So in other words, we've already found h of g of x, which is just this expression here, which is 1 plus x squared, which is also this expression there. So in f, where there's x, I'm going to replace with this expression because we've already found it. So in f, while there is x there, I'm going to replace with this expression or that expression. So we're trying to find f of h of, okay, let me just write it properly. I'm trying to find f of h of g of x. So which is just replacing what is x there with 1 plus x squared. So this is f of g of x. If you want, you can just multiply 2 to everything that we have in this quadratic equation, which will give you 2x squared plus 4x plus 2. And the domain of this expression will simply just be all real numbers as well. It's also a quadratic equation. You can put any number in this, any real number in this expression, the answer will still be defined. So let us now try to find this. Okay, so in this one we first have to find h of f of x, which is in h we're going to replace with f. So in h I'm going to put f of x. So h of f of x is simply just going to be In h, where there is x, I'm going to put f of x. So I'm going to have something like this: 2x and then squared. This will give me 4x squared. And then to add g now, we're going to say g of h of f of x. In g, where there is x, I'm going to put this expression there, which is 4x squared. So in g, where there is x, I'm going to put 4x squared. So I'm going to have something like this: 1 plus 4x squared. So this is also a quadratic equation. The domain for this expression will still be the same, to just be the set of all real numbers. So if you want, you can write it this way, or if you want, you can write it in this way, or if you want, you can use the set builder notation form. Yeah, so using the set builder notation form, you can say, if you want, you can use the set builder notation. If you want, you can use the interval notation. So the interval notation, you just say the domain is equal to from negative infinity to infinity. Using the set builder notation, you can also write it. Yeah, it's also straightforward. Alright, so thank you very much for watching today's tutorial. If you have any questions, feel free to contact me on any of my lines that I showed you on the screen. And don't forget to subscribe to the channel. My name is Hamted. See you in the next tutorial video. Shalom, shalom.